text transformation, you need to have 3 concurrent tracks, right? So in the first track, it is the text documents which we are dealing with. In the second track, we are dealing with the second type, possible types of content, and that is what it is possibly the internet link or maybe any web link actually. So that's what we have taken in the previous class. You can see here, right? So let me enhance it first. So that's what we have taken. So in the first possible flow, we could have text as input, right? And in the second track, we could have actually the second type, which is link, and the third possibility is metadata. So we will be discussing upon link kind of content, how to process it, how to extract it, and how to transform it, and this metadata part in the coming lectures, right? So we'll try to finish this in last 2 tracks of text transformation in the next lecture. Today we are going to discuss a lot about basically these basically remaining steps like stemming, right? Because stemming is one of the very critical processing involving text transformation or text processing itself, right? So typically stemming is basically dealing with the semantics of the text, right? So when I say semantics, so because these two first steps, stopping and parsing, they are basically naturally performing transformation on the word. So whatever content we have extracted from the internet or maybe from any web source, through parsing and stopping, we have performed some kind of removing the word or removing the content, removing some components of the text, or maybe sometimes we are transforming also, right? So these 2 first steps, parsing and stopping, are designed to perform some kind of denoising, because we are removing some text in the stopping, and in the parsing we have performed some sort of transformation. So these 2 first steps, parsing and stopping, are basically dealing with syntax and the content or maybe redundant content. But when it comes to semantics, because whenever we are having text as an input, we should be thinking about the possible semantics, right? Because whenever we are having text, there is a possibility that these texts will be having some variations or derivations of the text, right? So let's take 2 possibilities. So you can read here. So let me further enhance it. So yeah. So here you can see, if you have these kind of text appearance, so suppose in the text or in a paragraph of 100 words, these different terms are placed, like we have fish, fishing, and fishes. So these three are all these three terms are valid terms, right? And but as far as search system, as far as index data point of view, it is very critical to keep all these 3 terms, because eventually whatever transformation we are performing, so the objective of transformation is to reduce the size of the content, right? And to place only potential terms, right? And these terms will be converted into the index terms or important terms, and will be stored in the index database. So eventually it is the responsibility of parsing, stopping, and stemming component, which terms needs to be kept or assumed to be important, right? So by parsing we have achieved some sort of denoising. By stopping also we have performed some sort of denoising or removing the redundant or maybe repeating terms. And now there is a third possible implement which we are achieving through stemming also. Stemming basically deals with all the derivations or the differently generated or created terms related to a particular root word. We are referring to root word term here. So we are dealing with those all possible derivation of a text terms within the extracted data. So naturally, arrangement should be like, naturally the very first step is the parsing, then we will be performing stopping, and the outcome of stopping component will be fed as a input to the stemming term, right? So this is the possible suggested arrangement. It is not necessary to perform stopping. Just you can have parsing and stemming. That could be one arrangement. You could have only parsing. It is not necessary to keep always stemming, but parsing is important. Last two steps, stopping and stemming, are optional. It is up to your application. It is up to your understanding of the problem scenario. Based on that, you can adapt the arrangement of these three components. But parsing is basically, you can say it is a mandatory, right? And these two, stopping and stemming, are optional. So you can assume in this position, right? So these parsing is basically is optional. Parsing is mandatory, and stopping and stemming is optional. So you can arrange these two terms in based on your understanding. So if you are adapting both stopping and stemming, then stopping should be appearing in the first step, right? Because it is removing a lot of terms which will be having a lot of over work or overhead to the stemming component. So because stopping is primarily removing some content, some terms, some words, so it is always better to keep stopping component first, then output of stopping will be going to the stemming component, right? Now, so we are assuming that after performing the stopping process, yes, in the text or in the processed text, there could be these kind of scenario where there are various terms related to one keyword or one root word is available or is existing. So we should be removing those all possible derivation and have only this root word, right? So suppose in a text these three terms are appearing, fish, fishing, and fishes. So instead of keeping all these three terms in the text, we could have placed only one occurrence of fish, right? So you need to replace all these three with fish. Then you could have only one instance of appearance of this term, right? So primarily, this stemming involves two primary steps. So first step is to identify all these terms or all these words, and then so these are the terms these are the words which we are referring, and then you have to map all these terms with this keyword, this root word, right? So it is many to one mapping. So you need to identify all these terms, then you have to map it with root word, right? That is the objective actually. So by this way, we could achieve some sort of, again, some sort of denoising of the text. So eventually the objective is to achieve lesser size of text, right? Similarly, you could have the presence of these terms like prove, probable, probe, and probable. So in this case, in the very first case, we are having three different terms for three different references. These three are three different references because the first term is referring to one scenario, one particular situation. Second is referring to a process. Third is referring to again the nouns, right? So basically that could be one typical scenario where we could have different forms of a term, forms of a verb, forms of a root word. But typically in the second case, if you see, we have proof, probable, probe, and probable. So these four terms are naturally related to one single root word, which is probable. But these three are altogether are used in four different contexts. So it is very sensitive task also. So whenever we are performing stemming, it is very important to maintain the semantics also, because semantics means the reference or the context which each term is generating or creating in the text, right? Because each term, though all these four terms are related to one single root word, but both these all terms in the documents are referring to different contexts, right? So you might have some kind of familiarity with these terms. Like in the text, we could have synonyms, then we have homonyms, homophones, and then homonyms. So these last two cases are important when you are planning to design voice enabled search system. because in that case you will be submitting your inputs in the form of voice, right? So that's why for text search system or text based search engine, these two terms are not having much of impact, at least for text transformation, right? But if you're designing voice enabled or voice enabled search system, then these two terms are, these two scenarios are very important. You should be always concerned about how you will be dealing with homophones, because in case of homophones, two terms will be having altogether different spellings. Then both terms will be delivering different meanings, but sound will be same. So having same sound for these terms will be confusing for the search system. So you should have this mechanism to differentiate, and naturally you should have a mechanism in the text transformation also to differentiate these two terms. Similarly, homonyms are also a problem, because homonyms are the text terms in the collected data with the same term, basically spells are also similar, spellings are similar, meanings are different, but sound is same. So it is very close scenario. So it is very important to have different, within the stemming component, you could have different algorithm, different, code sections which are dealing with these type of possibilities in the text, right? Synonyms are also a typical problem sometimes, because here terms are naturally different, but they are delivering the similar content or similar meaning. So they are having a very specific challenge, which we will be discussing in the upcoming lectures also. So stemming is broadly created to identify the possible derivatives of a term, and naturally if you want to remove this derivation, you need to remove that added part into the term, right? So it is basically, it is considered, or it is referred as a mapping process. A mapping process basically, which is mapping the received term or received word in the text, and basically its relation, generating or identifying its relation with its core or root word or core concept, right? So stemming is now, it is very important, just because it is basically avoiding the removing the inflection or deviation from the text received. And basically after this stemming part, the whatever terms we will be having with us will be directly sent to the index data or indexing process, right? So when we achieve these root words, naturally after stemming, whatever terms we will be having with us, all terms will be a form of root words or maybe stems, right? So here we are using these two terms, root word and stem. So you should be having this clarity that root word is a different, when it is having different meaning, and stem is different, right? So when we say root word, it could be any term with removed deviation based on some logic. But when I say stem, it means there is a term in the dictionary, there is a term in dictionary, a valid term or a meaningful term, on which we have added something onto it to make a deviation or to make a derivation. And during this stemming process, we are removing the deviation in the term by keeping its meaning, right? So whenever we are designing an algorithm and we are saying, okay, by these logics we will be removing some some extension, some suffix or prefix to the term, to the English term, but it is not necessary that in all possibilities, in all steps, you will have a valid term. Sometimes we are creating invalid or meaningless terms also, right? So that's why it is kept as a root word, right? So achieving the root word does not mean, performing stemming does not mean you will always have a valid or meaningful root word or meaningful term, right? Whenever we are saying, okay, we will be performing stemming and making sure that there will be a meaningful term. So these two are two different cases, right? And that is the difference between two types of stemming processes, right? So in some cases, in some algorithms, maybe in the literature or maybe in the existing approaches, in some cases it is difficult, in some cases or maybe in some algorithms, it is difficult to achieve the valid English term or valid language term in all cases, in all text inputs, right? But in some algorithms, this has been improved, and they are claiming that the possible outcome of a stemming algorithm is generating a valid or set of valid terms in this scale. So that is the difference between a algorithm or maybe a optimal or a better stemming algorithm, right? So because so this valid terms or number of valid terms generated by a stemming algorithm is one of the performance criteria for a, or maybe for the comparison between two stemming algorithms, right? And if you see carefully, or if you observe carefully, if we have valid terms after stemming process, naturally it will perform some kind of a role in the ranking process or ranking phase during the search process. So it is having very minute, although it is having very minute contribution in the ranking process. It does not have any. Does not have any impact during the matching process. It should be very clear to you now. Now, if you consider this fact that all the possible algorithms of stemming are basically of two nature, right? One is of type algorithmic based, right? You could, so in this case of algorithmic based stemming algorithms, you can design your own code and write, okay, this is how I will be dealing with the possible extension, possible suffix of a word. So if you have an input as an English word, then you can design the stemming algorithm for all the possible these kind of terms. Like if you have words like plural words, so you can design a set of steps, set of code lines to remove these S, ES, all those things, right? Similarly, you can have other exceptions. So in the case of algorithm-based stemming algorithm, you can write your own instruction, you can write your own exceptions and design an algorithm to perform stemming. An objective in the case of stemming approaches to remove these deviations, to remove these derivations from the English words which we have with us. Now, similarly in the case of dictionary-based approach, the focus is same, aim is same. Aim is to remove these possible derivations or possible suffix in the English term. But here, in the case of dictionary-based approach for stemming, you will be having the support of dictionary, right? So to perform any kind of stemming in the dictionary-based approaches for stemming, you will have the support of dictionary, right? So in both cases, naturally, you have to make some kind of rules or some kind of arrangements. Like in the case of dictionary-based approach also, to perform stemming, you will have this support of dictionary, right? So language dictionary. So like if you're designing a stemming to perform stemming on the text, English text, you could use any Webster dictionary or any dictionary. Similarly, if you're performing the stemming on the Hindi literature or Hindi text, you can use dictionary of, any Hindi or well-established dictionary of Hindi. Similarly, for any language-specific transformation or language-based transformation, you could adapt that particular language dictionary. But again, how to reach to the root word or stem word, you need to design a algorithm, right? Similarly, in the case of algorithm-based approach, you need to write some steps. Then if you face some exceptions, if your algorithm is creating some invalid terms, you need to add some exception onto your algorithm, your stemming algorithm. So both in the case of both algorithms, you need to perform some kind of scalability. You need to scale your algorithm. In the case of algorithm-based stemming approaches, you need to add some steps, some exceptions. In the case of dictionary-based approaches, you need to update your dictionary, right? You need to insert a lot of newly occurring words, newly added words in the dictionary. So in the case of scalability, you need to update both. In case of algorithm, you need to add exception. In case of dictionary-based, you need to add new words into the dictionary, right? So these are the two. So whatever algorithms we have, so nowadays, till now, so these are the possible so-called established stemming algorithms we could have. If you explore to the literature of stemming, in the internet or maybe in the scientific documents, you will be finding, or you will be having these all possible so-called fundamental types of stemming approaches, and these 5 or 6 fundamental approaches, as well as the proposed or updated, all these kind of stemming algorithms are falling between these two types. One could be an algorithm, one could be a dictionary, or naturally third could be the possible hybrid of that, right? So naturally, because in the modern computing assumptions, people are going for the hybrid built solutions. So you can design your algorithm-based stemming algorithm, then you can add dictionary into it to improve its performance, to improve its accuracy for the stemming process, right? So one thing is very obvious, that stemming is to create stemming is to identify the root word by simply separating or denoising or removing the deviated or derivations of a root word. So whenever you are removing something, whenever you are taking off is the absolute term we can use. Whenever we are taking off something from English or from any language term, there could be two possibilities, whether it is be too small or whether it will be too much, right? So these two possible cases are often considered as the stemming error also, right? So you can perform a stemming, and during this stemming process, there is two possibilities, that you are removing too less number of alphabets or terms within a text word, or you are removing too much of terms, so it is losing the meaning. So in both cases, in both scenarios of stemming errors, understemming and overstemming, you will be creating a lot of invalid, meaningless terms actually, right? So to deal with these two issues, understemming and overstemming, naturally you need to have some kind of supports, right? Like in case of, so that's the reason also. So to basically improve our algorithm-based approach for stemming, you could add dictionary to resolve the issue. So whenever we are saying your algorithm-based stemming is not performing good, it means either it is creating too much of understem words, or it is creating too much of overstem words, something like that. Similarly, in the case of dictionary-based stemming approach, if you are facing understemming, it means it is not taking, or maybe new words has been established. And if you're performing overstemming, it means there are a lot of words has been added into the dictionary, but system or maybe your approach is not picking those newly introduced words. So you need to change your algorithm also in case of dictionary base also. So in both types of stemming approaches, algorithm and dictionary, we could have situations of understemming or overstemming, right? So you should be identifying these possible errors in your stemming algorithm, and based on that, you need to perform some scalability changes into your algorithm, right? Now, if you are designing an algorithm naturally based on one of the approach, and if your input is language specific, right, language specific, then you should be having very careful approach to create the stemmer program, right? Because most of the languages, like English is one of the rich language as far as stemmer concerned. You can have a dictionary for that, you can have algorithm also, because for English term, proper English language, you could have support of Greek and Latin dictionary also. So there is a lot of support available in the internet or maybe global platforms. But if you go to a specific language like Hindi, Urdu, or so any maybe regional or maybe country specific language, it is very difficult to create a stemmer for that particular language, right? So basically, it is one of the key challenges. So whenever you are designing a system to deal with any language, and in that you are designing a stemmer program as a part of text transformation component, it is one of the challenging tasks to design a stemmer to the text transformation, right? And it is just because in these languages, in these regional or maybe country specific languages, these derivations of particular terms or particular word is very high, but we are not having these terms, these words as in the recorded repository or corpus, right? So this is one of the challenges. So when in future, whenever you will be designing a solution, you will have this problem with you to be resolved during this stemming. So you should always design a stemming algorithm by having this balance, that okay, for algorithm based stemmer, I will be taking the support of dictionary, or I will be taking off a support of any corpus, or maybe some bag of words kind of arrangements, right? So you can create your own bag of words to support like dictionary based or to support algorithm based stemmer also. Like in the previous lecture we have raised this example of Google search engine. So nowadays, not nowadays, from the last 8 to 10 years, now each search engine, not Google search engine, each search engine is having their own bag of words support to the dictionary. So for any search platform, for any user related operations, they are having support of dictionary. Naturally, they are having algorithm based stemmer, and then this algorithm based stemmer is supported by dictionary and with their bag of words, right? So because they are assuming that sometimes user typed keyword is also very important, because it has been observed that most of the users of a country, or maybe the regional area, are typing the same keywords. So they are assuming that that term or word or keyword could be of a meaningful or purposefully typed. So they are creating bag of words to support the stemmers, right? So now, if you so this term we have said that okay, possibly in the literature we have Potter's is one of the established algorithm for stemming. Then we have Lomans, Dervisons. So these are all the authors' name for these algorithms, right? So Potter is basically kind of algorithm-based approach. So there are two authors. One of the author name is Potter's. They have created their own set of instructions, set of so conditions. Based on that, you can perform a basic fundamental way of stemming, right? So same kind of so you can create your own version of Potter's algorithms. So Potter algorithms is one of the widely accepted algorithm based stemming, because it is easy to adapt, it is easy to modify. You can add your own exception onto the algorithm. So algorithm is widely available in the platform. So whenever you are designing a search system, so in that, if you want to design a stemmer, you can take out the code of Potter's algorithm and simply add some exception into it, and you can achieve some sort of stemming, right? So it is broadly designed for English based text, right? It is easy to adapt, it is easy to scale, right? And it is basically it is generating significantly or some sort of satisfying level of performance of stemming. So after that, we have this Lovins and Davison and Snowball. So all these algorithms are based on this algorithm-based approach. They are having their own algorithms, right? Naturally, in the Potters, they have observed some some sort of performance lag. So they have come up with their own proposed idea, and they have their own set of instruction to perform stemming. And after that, there are this algorithm by Krovetz. Krovetz have proposed the very first approach, which is having this hybrid mechanism of algorithm and dictionary-based approach for stemming. So that is considered as one of the successful stemming algorithm, because by adding the support of dictionary, you could significantly remove or minimize the effect of stemming errors, right? Because through dictionary, you can control the generation of incorrect stems or incorrect transformation of a text string, right? So Lancaster is one of the dictionary-based approach which has been popularly utilized or used by the different researchers, right? So if you open into the Potter's algorithm for stemming, naturally it will have a set of rules, right? Set of rules you can modify also. You can take out the algorithm and modify these rules also. But in the fundamental or the very first version of Potter's algorithm, you will have given some rules, and naturally in the fundamental version of Potter's, there is no exceptions. There is no exception has been added, but you can add your exceptions. So that is what the modified Potter's algorithm is listing also. So you can say the Potter algorithm version 1, they are not having any exception, but when they have modified it, maybe after 10 years, they have added some exceptions, and they have suggested the observation that whenever you want to deal with some stemming errors, you can add some sort of exceptions into the algorithm, to the Potter's algorithm, to remove that stemming error, right? The main drawback or the main limitation you can say of Potter's algorithm is that it is primarily designed to deal with English language specific text. So you cannot use Potter algorithm to adapt to maybe Arabic or maybe to any other language beyond English. So that is one of the bottleneck, and that is one of the basically criteria to select the Potters on or go for beyond algorithms, right? Though all these alternatives which we have taken, Potters, Lovins, Jefferson, Snowballs, all these are primarily designed to perform stemming on English specific text, but there are various language specific stems are available nowadays. So if you are dealing with English text, there are some stemmers designed by Indian researchers also. If you are dealing with Arabic or maybe any other Parsi or any kind of language, country specific or regional specific, you can have always these stemmers. There's these stemmers where codes are available in the internet on the basically researchers platforms. So you can basically take out those codes and modify these codes for your purpose, right? So it is basically Potters is one of the oldest basically approach for stemming or established stemming approach, and it is basically producing stems. I'm saying stems, not words, right? So it is not creating the valid word some kind of. So it is simply creating the original word, right? So basically, if you want to read out much or internalities of basically Potter's algorithm, I will be sharing a pseudocode form of notations. So you can go through these steps or these rules, and in the notes which I am sharing along with this lecture note, you can easily go through these steps, and along with the steps, there are some examples provided, right? So like for rule number 1, so this Potter algorithm will be having only five steps. So for each step, naturally within each step there are 3-4 rules given. Like whenever in text double ed is there, it will be converted into ed something. So it is very very generic way of rules written in the text. So by reading these set of rules, set of steps, you can also perform similar kind of, you can also exercise similar kind of stemming. So in the supplementary notes, these steps will be given. Along with them, there will be example given, right? Because of this rule, this is how stemming will be performed. So you can easily understood the rule, and you can easily understood the examples or how it is affecting these stemming in these words, right? So you can easily understood this whole approach of Potter's, because stemming is a very generic process, because it gives the user perception to the search system that this is how user is also intended to apply his keywords, right? So you can easily read it out and easily understood the internal logic. Right. So let's go to the second approach, which is proposed by Krovetz, and it is one of the first approach which has been considering the role of a dictionary for the algorithmic-based stemming approach. This is one of kind experience, and it is significantly having contribution or presence in the literature domain also. So if you will explore to the literature of stemming, this Krovetz is one of the established approach, and its success is primarily coming from the presence of dictionary to perform stemming, because most of the algorithmic approach are having very lesser level of performance, accuracy performance in the stemming, just because they are having set of rules or they're having some sort of exception into it. But when Krovetz have proposed this approach and said that, okay, in the algorithmic, if we add dictionary support, this performance will be going up to 90 or maybe 96%, something like that. So it was a milestone solution for the NLP based solutions, particularly whenever we are dealing with some sort of text transformation and we are performing some stemming, right? Again in this also, because it is well supported by the dictionary component to perform stemming, then you need to have updated dictionary with you. So again, dictionary update is one of the key challenge. It is one of the bottleneck factor, because this basically accuracy of this whole stemming approach is based on the updated terms into the dictionary, right? So if you compare the performance of these two approaches of stemming, so let me take out a simple input text. So I hope you can read it. It is visible to you, right? So this is your input text. This is your input text, a typical input text. Naturally, in this input text, we have performed some sort of stopping. And that's why we are not having these stop words in the these bottom two outputs. So for this given input text, we have performed parsing as well as stopping. That's what is the resolution here. After doing the parsing and probably stopping, if you perform a Potter-based stemming in the text, you could have this sort of output. So you can carefully observe. We have achieved some sort of transformation in the input text, and based on this transformation, you can see there are a lot of words which are basically incorrect or invalid or maybe meaningless terms, right? So I mean, it is the feature of Microsoft Word also. Now it is underlined or highlighting the incorrect words, like describe is incorrectly written, strategy is, carry is different, agriculture is incorrect, all these terms. So all these terms which are underlined by the red kind of underlining by the Google, like by the Microsoft Word itself, these are the incorrect words generated because of the logics built into the Potter's algorithm, right? And basically, naturally, number of words will be reduced. So in the input text, we have total number of words of 44, and because we have performed parsing and basically this stopping thing, so we have reduced the size of text as up to 44 to 32 naturally, and naturally we have transformed the different words because of some logics of Potter's stemming approach. And if you see carefully in the Krovetz stemming, which is well supported by dictionary, all these invalid terms like describe, strategy, company, carry, agriculture, pesticide, stimulus, these all words has been correctly stemmed, right? So there is no basically kind of no incorrect word has been created in the Krovetz, except agrochemic. Agrochemic might be a word. You can see in the case of Potter's, it is incorrectly created, agrochem here, and in case of Krovetz also, agrochemic or agrochemical word is transformed or stemmed as a agrochemic. Now in the whole text, we are observing that there is only one incorrect word, agrochemic, and that might be because of this word or this term is not created or inserted into a dictionary. If that term is added into the dictionary and your dictionary is updated, it will be rectifying this issue also. It will be correcting this agrochemic term as a correct term also, right? So now you can observe here this total word is also less than 30. So if you compare as an input, we have got 44 words. In case of Krovetz, we have got 30. So there are this term called market share, which is appearing here twice, here as well as here. But in case of Krovetz, this market share is having only a single presence. So naturally, it is performing or it is removing some sort of repeated terms or repeated dictionary terms also, right? So this is a typical. So by this example, you can clearly establish two facts that this is the impact. the impact of dictionary could be a significant role into the this stemming process. So that's why in the modern applications, in any kind of modern NLP based applications, these stemming process or stemming task is achieved by the support of dictionary, right? Though sometimes it is a challenge also to update the dictionary and create the dictionary also. So like in case of English text, it is a privilege to have these established dictionary by Oxford, Webster. A lot of dictionaries are available. But when we go beyond this English literature or English text, it will become one of the bottleneck also. So most of the language specific stemmers are designed by using some sort of corpus, some sort of bag of words approach, because there it is a very challenging task to get a proper dictionary, right? So whenever in situations you are having this problem that okay, we don't have the support of, we don't have ability of dictionary, you can go to create your own corpus, your own bag of words by processing the established document of that particular language and create your own dictionary or support document, support terms, and then you can achieve some sort of algorithm and bag of word based approach for stemming, right? So with this, I am closing today's lecture. Let me partially share the second content, which we are seeing as a support notes for the today's lecture. So this is typically this is how we have prepared proper notes, a proper stemming algorithm. So you can here see in the Potter's algorithm, the very first step says you should be transforming or converting whenever we could have SSES as a suffix in an English term. You should be simply transforming it to by SS. So like in the English term care, you can simply replace with cares, right? Simply if you are having any presence of IES as a suffix into English term, you should be simply replacing it with I. So it will become pony, something like that. So ponies becomes pony, ties become tie, right? So if you are having appearance of double S in any as a suffix in any English term, it should be simply having SS. So it will be likewise. So similarly in step 1B, again it is having similar transformation. So to understand these logic steps, there are some examples placed. So by these examples, you could have a very clear idea about the possible transformation on the text, right? So it is having specifically 5 different steps to perform, and these 5 steps are basically coming from the fundamental or maybe you can say original Potter's algorithm, right? So whenever you want to add, whenever you want to modify this algorithm for your purpose, you need to add exception rules, right? So again, these exceptions will be in the form of rules only. You can add the step 6 as exception, and naturally exceptions will be dealing with some sort of term, some sort of word, some sort of suffix into the English terms. And for those English terms, you need to write these basically steps or rules, right? So with this, I'm completing today's lecture. If you want to raise something, discuss something, you can raise here. Thank you.